Hello! In this video, we will be covering Redux. Here's a list of all the topics that we'll be covering in this video. You can jump to a specific topic by clicking the time link in the description below. We'll be moving really quickly, so feel free to pause and replay if you need to. So first, here are the two highlights of Redux. First, Redux helps apps to scale by providing a sensible way to manage state through a unidirectional data flow model. An app without Redux may have 50 components that each have their own state, and they may talk to each other and update each other's state, and so the state of the app as a whole becomes extremely convoluted and confusing. An app using Redux, on the other hand, has one place where the master state of the entire app lives, and components send requests to update that master state, and then state changes to the master state flow down to all of the components. You can easily know the entire state of the whole app. Second, Redux Devtools is awesome. It's a browser add-on that lets you inspect the Redux state easily, which means you can debug your app easily. There are lots of other features in Redux Devtools that help a ton with debugging. Now let's talk about the store, actions, and reducers. Basically, the store is where the entire state of your application lives, and it's basically just one big object. Actions are sent or dispatched from the views, which are a payload that can be read by reducers. Reducers read the payload from the actions and then update the store or the master state accordingly. So now let's learn how to set up Redux. A lot of people say that setting up Redux is really tedious, but it's actually not that bad, and it's worth the effort. Let's start by installing Create React App to give us a basic React app as our starting point. To install this, you'll need the latest Node, so go to nodejs.org and download it. And then let's do npx create react app redux tutorial. And then let's cd into the directory like that. Let's do yarn add redux and react redux. And then we will do yarn start to start our app. And then let's open up the project in our text editor. I'm using Sublime Text here. And then let's open up index.js. So first, let's learn how to create our store. Let's first import create store from Redux. And then let's do const store equals create store. Import and const are features of ES6 syntax. If you're unfamiliar with ES6 syntax, I'll try to explain as we go through this tutorial. And when we save, we'll see an error saying that the reducer needs to be a function. We need to pass a reducer into create store. So let's just create a really basic reducer function right now, and we'll explain more about it later. Let's do function reducer, and then let's just have it return state. Then let's pass this reducer into create store, and we'll see that the error has gone away. Now we can console log store.getState to see the state of our store. And since our reducer is returning the string state, that's what we see in the console. Next, let's learn how to dispatch an action. First, let's create an action, which is basically just an object with a type and a payload. Let's write const action equals and then an object, and the type will be change state. And the payload will be an object with new state and new state. Now let's send this action to the store by doing store.dispatch and then action. Next, let's learn how our reducer reads an action to update the store state. Reducers have two parameters, the initial state of the reducer and then the action. Reducers listen to every single action that is sent, so they need to be able to figure out what to do differently for each action. Let's first just console log the action to make sure that the action we just sent is reaching the reducer. And we see in the console down here the action that we just sent, and it has the payload with the action too. So to act upon the action that we just sent or dispatched, we can do if action.type equals change state, then we will return the action.payload.newState as the new state. Then if we console log store.getState again at the bottom, we'll see that the state has changed to be new state, which means that our reducer successfully updated the store based upon the action that it read. Now, the state of our store is currently not practical at all. It's just a single string. So now let's make it look like something that we might see in the real world. Let's start by making the store an object with two different properties. Let's say products and user. To do this, let's start by also importing combined reducers from Redux. We want to have a reducer for products and a reducer for user, and we will be using combined reducers to combine them into a single reducer to pass into our store. Then let's delete this code down here that we don't need anymore. Then let's change the name of the reducer up here to be products reducer, and let's say that the initial or default state is an empty array. Then let's delete this code up here and let's just return state for now. Then let's create another reducer called user reducer, and its initial or default state will be an empty string, and it'll also take an action. And let's just return state in there also for now. Then let's combine these two reducers into a single reducer by doing const all reducers equals combine reducers. And then let's pass in an object with products as the products reducer and user as the user reducer. And then let's replace reducer down here with all reducers. And now when we save, we'll see that the state of our store is now products with an empty array and user with an empty string. Now our store looks a lot more like a real-world store in an application that is prepared to scale. Imagine an app that continues to grow and adds lots of pages and components. Each of these pages and components could have their own properties within the store to keep their state distinct from one another, and yet all of their states are easy to find and see within this one master store object. Now let's learn how to set an initial state for the store. Sometimes we want to pre-populate our store with data, especially if we're doing server-side rendering. To pre-populate our store, we simply pass in the initial state as the second argument. So let's pass in an object with products as an array of one object with name iPhone and user of string Michael. And now when we save, we see that the state of our store is the initial state that we're passing in. Next, let's learn how to set up and use Redux Devtools. First, find Redux Devtools in the Chrome Web Store and add it to Chrome. Next, we want to pass in a third argument to create store, which contains all of our store enhancers. So let's do some reformatting first. Let's move the first two arguments to their own lines so we can differentiate them better. And then let's add a third argument that says window.devToolsExtension, and then window.devToolsExtension with parentheses. Basically, we're checking to see if the browser has Redux Devtools, and if it does, we want to call DevToolsExtension and pass that in as the third argument to create store. Now let's save and then go back to the console. You may need to restart your browser to see it, but you'll see that the Redux Devtools extension has added a tab at the top called Redux. And if we click on it, that's where the Redux Devtools are. Then we can click on State, and we'll see the state of the store or of our application. And we can inspect it by opening up the products object, and we see that it has our product of name iPhone. Now let's update our store and see what happens. Let's create an action creator called updateUserAction with type updateUser and payload user, let's say John. And then let's dispatch that action with store.dispatch updateUser. And then in the user reducer, let's use a switch statement, which is standard practice for reducers. Let's do switch action.type, and then if the case is update user, we will return action.payload.user. Let's save. And now when we click State in Redux Devtools, we'll see that the user is now John. And on the left side, we'll see the action that we sent, which had a type of update user. And if we click on the thing above update user, we can basically rewind the state of the store. This is great for debugging to see exactly how the state of our app is changing. Some people call this time travel debugging, and it's a really powerful way to debug problems within the app. Next, let's just do some code cleanup. In the parameters of user reducer, we can use ES6 syntax to destructure the action to be type and payload, and then we can get rid of the action dots below. Then let's delete the code down here that we don't need anymore. Next, let's learn how to use provider to give our app access to the store. First, let's import provider from React Redux. And then let's wrap the app component below with provider, and then store equals store. And then let's close the tag. Now our app can access the store, and soon we'll learn how it can access the store. But before we do that, let's do some file reorganization. Obviously, if our app is going to grow, we won't keep all of our reducers and actions in this one file. So let's first create a folder called reducers, where we'll keep all of our reducers. Next, let's create a file called productsreducer.js. Then let's copy the products reducer from index.js and paste it into the products reducer file. Then let's do export default in front of this function. Then let's create another file called user reducer. And let's copy the user reducer from index.js and paste that into this new file. And then let's also add export default at the beginning here too. Next, in index.js, let's do import products reducer from /reducers/products reducer. And import user reducer from /reducers/user reducer. And now when we save, we'll see that everything still looks normal. Next, let's create a folder named actions, where all of our actions are going to live. And let's just create the two files for products and user right now, even though they'll be empty for now. So let's create productsactions.js, and let's create useractions.js. Now let's learn how to connect components in our app to the store. To do this, let's import connect from React Redux. Then at the bottom, we can call connect, and then we pass in the component after that. Connect can take 3 arguments, and we'll cover them one by one. First, we can pass in mapStateToProps, which basically receives the state of the store, and then we can use that state to decide what props we want to provide for that component. So now let's do const mapStateToProps above, and it'll be a function with the state as its first argument. This double arrow is just ES6 syntax for a function, and then let's just return the state for now. And now if we console log this.props above, we'll see that the state is logged to the console. And there's a warning here saying that we need a default case for our switch statement in user reducer. So let's add in default return state here. And then let's delete the return state below. Next, let's just be a little more specific in choosing what we want from the store. Let's specifically return products as state.products and user as state.user. The parentheses are to automatically return this object. The second argument that we can pass into connect is mapActionStoProps or mapDispatchToProps. This basically allows us to dispatch actions from our components easily, so we don't need to mess with using dispatch in the components themselves. We can just call functions that will automatically dispatch actions to the store. So up here, let's do const mapActionStoProps equals an object. Now let's just create an action to use here. First, let's rename the user actions file to be hyphenated instead of camel case. Then let's do export function update user, and then new user, and then we'll return type. And let's make the type into a constant since we'll also be using it in the reducer. Let's do export const update user. equals users, and then update user. The user at the beginning just scopes our action type to avoid collisions with actions in other components. Then let's use this constant as the type, and then the payload will be user, new user. Now let's write code in the user reducer to handle this action. Let's go to the user reducer file and do import update user from /actions/user actions. And then let's change this to be case update user, and then return payload.user. Now back in app.js, let's import the action so we can use it in this component. Let's do import update user from /actions/user actions. And then back in mapActionsToProps, let's put in the object onUpdateUser, :updateUser. I'm using onUpdateUser here to prevent variable collisions if we destructure in the component. Then in the render above, let's make a div that'll be a click event handler that will dispatch the action. Let's have the div say updateUser, and then we'll do onClick equals this.onUpdateUser, and then let's define the onUpdateUser method above. And since we'll need to access this in the onUpdateUser method, we need to bind it in the constructor. So let's do constructor props super props, and then this.onUpdateUser equals this.onUpdateUser.bind this. Then in the onUpdateUser method, let's do this.props.onUpdateUser, and let's say Sammy. And then underneath the click handler in render, let's just also display this.props.user so we can see it change. And now when we click on update user, we see that the user Michael changes to Sammy. Now let's turn this div into an input so we can change the user to whatever we want. Let's do input and then onChange equals this.onUpdateUser. And then in the method, it'll take an event. And let's pass in event.target.value instead of Sammy. And now as we update the input, we see that the user in the store also updates in real time. And you can see all of the actions that we're firing in the Redux Devtools below. Next, let's learn how to use props that are passed to the component in mapStateToProps and mapActionsToProps. Let's say we're passing a prop into the app component. So let's just go to app.js and do a random prop or props equals whatever. Then to access the passed in props in mapStateToProps, it's just the second argument. So we can add props as a second argument. And if we get rid of the automatic return and return the products and user as an object inside the function, we can console.log the props, and we'll see that a random props whatever shows up in the console. Then we can use this prop to customize the props we're giving to the component if we want. For example, we can return another property called user plus prop, that is the user and the random props prop together. This is ES6 string concatenation syntax that I'm using here. Now let's get rid of this console log here, and then let's console log the props above, and we'll see that our component now also has the prop we passed in, and also this custom user plus prop we just created. Next, let's learn how to access props in mapActionsToProps. This is a little trickier. mapActionsToProps can also be a function that has dispatch as its first argument and props as its second argument. Then in the function, we'll return the same object as before. But this time we need to explicitly bind dispatch to the actions in here. To do this, we will go up and do import bindActionCreators from Redux. Then back in mapActionsToProps, we'll wrap the object in bindActionCreators, and then the second argument will be dispatch. Let's save, and we see that everything still works. And now we can console log the props and see that we are indeed getting the aRandomProps prop in here correctly. And let's get rid of the console log in the render to be able to see it more clearly. And like above, we can use the passed-in props to customize the action creators that we are making here. Next, let's learn about the third argument that we can pass into connect, which is mergeProps. So let's do const mergeProps equals, and then mergeProps takes three arguments: props from state, which is basically whatever we return from mapStateToProps, props from dispatch, which is what we return from mapActionsToProps, and ownProps, which are the passed-in props. And let's just return an empty object for now, even though this would mess up our component, since the result of mergeProps is what the component will receive. Let's console log these three things out. So props from state, props from dispatch, and ownProps. And we need a double arrow here. And we'll see that we get these three objects in the console: props from state here, props from dispatch here, and ownProps here. Next, let's learn how to do API requests with redux-thunk middleware. First, let's go to the terminal and do yarn add redux-thunk and jQuery. Now we want to add the redux-thunk middleware to the third argument, which is basically our store enhancers. To do this, let's add apply middleware and compose to our imports above, and let's do const all store enhancers equals compose. And then let's first put in our Redux Devtools code. So let's copy that from below and then replace the third argument with all store enhancers. And then let's paste the Devtools code up here. And let's refresh to make sure that nothing's broken. And we see that the Redux Devtools in the browser still works. Now let's add the thunk middleware to our store enhancers. So let's do import thunk from redux-thunk. And then in the compose function, let's add apply middleware, thunk as the first argument. I'm not sure exactly why, but the thunk middleware needs to come first or else it won't work. Now let's do a little bit of code cleanup. Let's delete the mergeProps here. Let's change the mapActionsToProps back into a simple object by deleting this code here and here. Then delete mergeProps down here. Now in the user reducer, we're going to add an action creator that doesn't return an object, but rather a function. We can return a function now because the thunk middleware will handle it. So let's first import $sign from jQuery to make our API request. We can use whatever we want here. I'm just using jQuery to keep things simple. Then let's do export function API request. And it'll return a function with dispatch as an argument, and inside of this function we'll do our API request. So let's do jQuery.ajax. We'll just choose a random URL here since we don't have a server. Let's say google.com. And then we'll have a success method that console logs success. And an error method that console logs error. And because of CORS, or cross-origin restrictions, we're going to get an error here, but that's okay. Now back in app.js, let's add the API request action creator to our imports, and then in mapActionsToProps, let's add on API request, API request. Then let's do component did mount. Then this.props.onAPI-request. And now, when we save, we'll see that the error is logged to the console because our API request produced an error. But the important thing is that our API request was sent by the thunk middleware. Now, back in the user actions file, we can dispatch additional actions in response to the API request. So let's create another action up here. Let's do export function showError. And inside of showError, it will return a type. Let's say showError. And it'll also have a payload. And let's define the type above as const show error equals users show error. Then in the error method below, let's do dispatch show error. So basically when an error happens, this show error action will be dispatched. Then in the user reducer file, let's handle this action by adding a case. And let's import the show error constant above. So case show error. And it'll return payload. Let's actually change the payload in user actions to be an object with user error. So then payload.user here. And we actually need to call the show error function here in the error method. And now if we refresh, we'll see that the user changes from Michael to error. It happened really quickly, so let's slow things down a little bit to be able to see it more clearly. In app.js, let's add a set timeout around the onAPI call. Let's put that code inside of the set timeout, and let's just say we want to wait 1500 milliseconds before we do that call. Now when we refresh, we see that the user is Michael, and then it changes to error. Now, if we wanted to make our response to the API request more robust, we could put another dispatch in the success method to respond to whatever we get back from that API request. So we would do something like dispatch update user, and then pass in response.newUser here. Obviously this won't work right now, but this is just an example. We could also dispatch an action right when the API request is made. Let's just call request made as an example. And we could change the types of these actions to be more explicit. So the show error type could be something like API request error. And the update user type could be something like API request success. And then if we had an action called on request, the type of that action creator could be something like API request request. You can customize these actions to be exactly what you want them to be. Now let's learn about reselect, which is a selector library for Redux. Below, here are 3 great reasons to use reselect. First, selectors can compute derived data, allowing Redux to store the minimal possible state. Selectors allow us to keep our store as minimal and clean as possible. Second, selectors are efficient. A selector is not recomputed unless one of its arguments changes. So for maximum speed and performance, we should use selectors. And finally, selectors are composable. They can be used as input to other selectors. So selectors are extremely customizable. Now let's install reselect by doing yarn add reselect. Then back in app.js, let's do import create selector from reselect. Then let's replace the mapStateToProps part with create selector. And each argument here is basically a function that gets passed the state. So for the first 2 arguments, let's do state, and then let's return state.products, and then state, and then let's return state.user. Then the last argument will be a function that receives the result of all of the previous arguments. So let's do products user, and then we'll just return an object with products and users. Again, this is ES6 syntax. And these should actually be user, not users. And when we go back to the app, we see that nothing has broken. And let's just get rid of this API request code here for now. Now we read earlier that selectors are composable, so let's try that out. It's good to create smaller sub-selectors to maximize the speed and performance of selectors, because if these smaller selectors don't change, then they are not recomputed. So let's do const product selector equals create selector, and then the first argument will be state, and then state.products, and the second argument will be products, and then we return products. Let's copy the selector below. And let's change the products to be user here. And then let's replace state and state.products with just product selector, and state.user with user selector. And this product up here should actually be user. And now when we save, we see that everything still shows up correctly as expected. Next, let's talk about smart and dumb components. In an app that uses Redux, you don't want every component to connect directly to the store. That would be overkill. Instead, for each major page or section of an app, we usually have a top-level smart component that connects to the store, and then each of the subcomponents that live under this top-level smart component will be dumb components that simply receive all the props they need from the top-level smart component. So the top-level smart component will pass down all the state and all the action creators that the dumb subcomponents need. This way, we keep things clean by having fewer components connect directly to the store, and everything just flows down from the one top-level smart component to the many dumb subcomponents below. For example, let's take a look at an example products page. And let's say that we have a top-level component called products page, and there are subcomponents inside the products page component called add product and products list. We would connect only the products page to the store, and the products page will get the products list from the store, as well as the action creators called fetch products and on add product. The products page component will pass the products list to the products list subcomponent, and the on add product action creator to the add product subcomponent. And the products page component will be the one that calls fetch products. In a Redux app, we want to try to minimize the number of smart components that we have, so we know which one place to go to find all of the logic for getting the state and the actions. And that's all for this video. Hopefully you found it helpful. I'll see you next time.